Hello everybody and welcome to another K2 webinar. Today we are discussing all things flat roof, so I hope you're excited. If you were here last week, you will know my name's Kyron Murphy. If not, welcome. I'm working here in the technical sales, and today I'll be joined by a colleague of mine, Roman. Roman, can you hear me? How are you today?
Yeah, I can hear you. Hello everyone, nice to see you again if we saw each other last time. Today we're going to start same as last time, I'd say. Karen, what do you think?
I think that's a good idea.
Okay, so if everyone's ready, we would start with a poll again to just see what kind of people are in the webinar, who's attending, like how much experience do you have with K2 already. So if everything's ready and everyone is ready, I would just start the poll now. Karen, you think it's good?
Sounds good.
All right, let's do this. First question. Are you using K2 base regularly? It's in German. I'm sorry for this. Let's just give him a few seconds, Karen, so we know.
So about 60-40. That sounds was pretty similar to last week. I think we have a
few more seconds.
Yeah.
Okay, I don't think anything will change now. All right, 66%. That's quite good.
Yeah.
Okay, what about the next question? Did you already use K2 mounting systems?
Oh, this one's multilingual. Hey, how good.
I'm excited to see the result.
I think that's about the same as last time as well.
About the same. Okay, yeah. Just give me a few more seconds. Okay, I think we're good. Pretty much everyone's voting up. So that's good. 70-30.
Yeah, so hopefully some people know what we're talking about.
All right. If not, we're here to help out. Okay, and the last question. It's a multiple choice question again. So which K2 mounting systems do you use? Mostly, all the time, maybe all of them.
Oh, very staggered today.
Oh yeah, changing a lot. All right. Few more questions, a few more seconds, and then we got it. Good.
Yeah, thank you very much, everyone, for answering that. That's very helpful for us in terms of what detail we can provide in these webinars, and it'll help us improve for next time as well. So thanks very much for participating. Roman.
Thanks also from my side. And I would just give the word to Karen now. We'll see each other later, and I'll try to answer your questions inside. Thanks, Karen.
Okay. Thank you. So just to start off what we'll be talking about today, as similar to last time, we'll just be discussing the equipment we have, and then Roman will give a software demonstration and show where some of this material is online. As last week, we have a Q&A section in the Zoom. If it's on your phone or computer, it will be down the bottom, Q&A. This will be the best place to ask any questions. Roman will be answering them via text while I'm speaking, and potentially he'll stop me and I'll be able to answer the questions for everybody if they're suitable for the audience. I'll be then answering them for Roman when he's doing the base software. So please use the Q&A section. It will be next to the chat section. We will also have a bit of time at the end where people, if they would like to ask questions verbally, they can raise their hand virtually, and we will be able to turn your microphone on, and then you can either ask myself or Roman your specific question, and we will answer it as best we can. So I think that's all for the introduction. Let's get this show on the road. So we have three main systems. for our flat roofs, and they are the Dome Classic, the Dome V, and the Dome 6. Each one of these comes in a double module, which is usually installed east-west, and they are shown here. And we refer to these as D domes. And they also come in a single-sided layout, which we call S domes. It'll become a bit more clear when we show the material, but first I just wanted you to show a small comparison between the three. And we'll go through each section of the layout, and hopefully it will become quite clear as to which is the best product for your roof. So we'll start with the bottom layer of all of these and look at the mats, the building protection mats, which you can see on the slide. So we have 3 mats for different systems. And they have different purposes. So first of all, we have the mat for our Dome Classic. And this is a mat that's really just there to protect the roof and from the rail. So it has a small amount of, or it's not designed for sort of to highlight the friction coefficient between the roof and the mat. It's more there for protection. So this comes with the Classic system, and the Classic system is the earliest system that we have. Following that, we have what we call the Mat V, and the Mat V goes with the Dome V system. You can see this is a little more designed. It's been made with like a honeycomb structure, and the geometry is designed specifically for a little bit of friction coefficient, but also to hold the rails in place. It'll become a bit more clear when we actually have the rails with it as well, what I'm talking about in terms of holding the rails in. Now we have a nice profile of there's some, for a bit more extra strength, the geometry here. And you can see there's also a lot less material as well. Moving on, we have the Mat S, and we refer to this as S for the speed rail. And our system, Dome 6, is built with the speed rail, as well as the Dome Classic, but that is just the reason for the naming convention. Similar to the Dome V, it's been designed with a bit more friction coefficient, and it's very firm on the ground. Moving on from the mats, we will now go to the rails, just working our way up from that picture before. So the rails we have first up is the speed rail for the Dome Classic. And so we use the speed rail for other systems as well, for our trapezoidal roof, which we'll be discussing next week, I believe. And this just sits on the roof using the mats. Here's one that's already been pre-installed. And I'll just show you the process now of putting this mat onto this rail. These parts pop up, and it just sits like that. So this is how a Dome Classic system would sit on the roof. And this is what we would call a continuous rail or a long rail. So this differs from our other systems, which we would refer to as discontinuous or short rails. It's a little easier to see here why we call it continuous and discontinuous. So the top one, the rail runs the length of the whole module, the 2 modules, and then extends onto the next module. And we are able to have this rail up to 11 meters in length. So that is the distance we can have for a thermal gap. So the thermal expansion of the rail plays a part in that. And the rails come in many lengths and then are connected up to this 11 meters. Moving to the next one, the Dome V, you can see that the rail sits under 2 modules and then extends a little bit into the 3rd one. There is then a gap between the 3rd module and the base of the 4th module. and then there is another rail. So this is what we call a discontinuous rail or a short rail, and I will just show you that now. So here we have, these are more samples. They're a little longer than what these are generally. The lengths are given in our base report. So when you produce a system with dome V, either S dome or D dome, you will receive the lengths of what rails are required and the distances between the peaks. You notice the rail itself is very different as well. It's a lot wider than the speed rail. And this allows for a little bit of more ballast to be placed on it than the speed rail, but also allows this, this mat to be shorter. And the surface area is quite large on the mat because the rail is quite large. And this has the coefficient of, or the friction between the mat and the ground can then be better than perhaps the speed rail that we saw before.
Kyron,
yeah.
I do have a good question. I think everyone would be interested in knowing this.
Yeah.
Thomas was asking the question, can we mix mats between Dome 6 and Classic system? Or can we use mats from Dome 6, but in Classic system?
So it is physically possible. The rails are the same. However, at the moment, our base software does not plan for this. And so the advantages of the mass S, which are higher friction coefficient and then potentially less ballast, are not calculated in our software. So you would still have the, and you would then have to install the mat S onto the rails, which is a lot harder process than the classic building protection mats. It's just like the longer, and it's a little bit more tedious. So the Dome 6 comes pre-assembled, and so you don't have to worry about assembling these mats. But if you were to do it yourself, it would be a little bit, or be quite time consuming. And the software calculation that we have would not give you the benefit of the design purposes for the mat. So practically, technically, yes, you could use it, but practically you do not gain any advantage from it at the moment. This may be something we do later on, but it's not happening at the moment.
Okay, thanks, Karen. Thanks for the answer.
You're welcome. Was there any other questions while we're here? Or? No.
So not for now. I think
yeah, it's all good, all good. Yeah, so rails, we've done rails. Let's just jump back to our PowerPoint for a moment. So we've looked at the base rails for the classic system, the base rails for the V system, and just for the moment, we'll ignore the Dome 6 because all of that becomes or arrives assembled. And so we'll now move on to the peaks and the SDs. And these are the things that which the modules sit on. So from the top on the Dome Classic, I will just show you the material for the D Dome, which we have in that drawing. So this is made out of aluminium. You can see it's one thick structure. The aluminium is quite thick, and it has two fixation points. So one here and one here. And this will just sit on the speed rail and then be attached with our K2 slot nuts, which, as I think the majority said they had used before, you were probably aware of the K2 slot nuts. Just before we install it, just to compare that with the Dome V. The Dome V, I think I forgot to say this before, but the Dome V is named because of this V shape. This is why we call it Dome V. And if you compare it to the D Dome peak here, you'll see the V is quite obvious. But you'll also notice that there is a reduction of material in this. So the geometry has been utilized a little better. The thickness of the material is much less. And there's only one fixation point, and that's right in the middle. All right, so this will save your installation time a fair bit, which is one of the advantages. We'll just show you now a little bit of how both of them are installed very quickly. So we have our classic system from before. It just sits on the rail without K2 nut. And so this happens, we just do this on both sides. If we compare this to the V-rail, the process is very similar. We will just sit this on the rail and attach with our K2 slot nut. Here we have two fixation points going to one fixation point, so it can be a little bit quicker. And then you're set up. So both of these represent the top side of the modules, also the high points, the peaks. We refer to them as peaks. This is a D-dome peak for the classic system. This is a D-dome peak for the V system. At the other end of the modules, we have what we call an SD, and very similar to that installation, the SD for the classic system is installed also with our K2 slot nut. So for the classic system, there is three fixation points. One at the SD and then two at the peaks. All right, and comparing that to the V-rail system, we actually only have one. So as we saw before, there is a discontinuous rail, and so this is just representing the setup, but perhaps we'll have our D-dome peak here. And then at the other end, the SD, we actually just have we have no fixation. So this actually just sits in the rail, which makes it a lot quicker. It is fixed, and it's fixed through friction effectively. When we put a clamp in, it explains it a little bit better, but they just sits into the rail like so. Excuse me for the noise there. And so your module will sit from here to here, and there'll be a gap in the middle. So until now, we have ignored, or not ignored, but have not spoken about the Dome 6. And that is because the Dome 6, the majority of these components come pre-installed. So we didn't really have to worry about how they fix together or how measuring the distances between these, because for each different module, the distances will be a little bit different, and the process of measuring all that out can be quite time consuming. So earlier this year, perhaps late last year, we introduced a newer product called Dome 6. It's very similar to the classic system, but everything is brought to a smaller scale. So instead of having a long continuous rail, each rail is effectively sits under one dome. And we can see that a little bit by the PowerPoint. So on the bottom here, on the where it says 140 millimeters, and this represents the gap between the two modules, there is actually a rail connector. So one rail sits under one D-dome, and then a second rail sits under a second D dome. And everything underneath the modules it either comes pre-installed or can be installed with pretty much a click, and I will show you that right now. So this is a bit of a smaller module, a smaller sample for the module. So generally for our D-dome systems, which is what we've been showing here, this would be 2.25 meters, a little bit shorter for the S-dome or the single domes. And these components come pre-installed at the distance or at the correct distance. So you don't have to worry about measuring this out or tightening them. They're already fixed. And the peaks or the are suitable for either the S-dome or the D-dome. And yeah, can you zoom in a bit, please, Klaus? And you see, similar to the V system, the geometry has been designed in a way that is to improve strength. There is less material being used. And it looks a bit fancier, to be honest. And we'll also notice that there is no fixation here at all. So when setting up the Dome 6 for the S-dome or the D-dome, for the peaks and the rails, we actually don't need any tools, which is can be increase the installation speed up to about 70%, we've found. Klaus, could you just zoom out a little bit? We'll show the installation now. Yeah, so, no, out, sorry. And the other way. Thanks. And so here, this is the midpoint for our system, and it's simply, we just slide in and we click. And so this is now fixed. And the reason we can fix this position is that the clamping is a little bit different for the Dome 6 than it is for the Dome V and the Dome Classic. It's just a click again. And we'll just jump back to the PowerPoint to show this. So on the top two pictures, hopefully you'll see the top end of the module is clamped on the corner as well as the bottom. So the distance between the two modules on the top are about 80 millimeters. And this is a fixed value. So the distance between the peaks and the SDs have to be changed for each module. The beauty of the Dome 6 is that at the bottom, the module is clamped on the corner, and on the top, it is clamped somewhere on the edge. So we go through this in a lot more detail in a Dome 6 webinar from earlier this year. That would be probably the best place to discover a bit more information about that. But the advantage is that the Dome 6 can be, as it is pre-installed, is a lot easier and a lot quicker to install your whole system. So working our way up, we've gone from our rails to our SDs and our peaks, and then finally we'll have a look at our clamps. So
Karen, before we have a look at our clamps, we have a question from one from the audience, from Thomas. He's asking if, like, everyone knows that sometimes we have to have some anchor points on flat roofs, which are higher than 3 degrees and even higher than 5 degrees sometimes. But so the question is, can we calculate anchor points? He knows the Solomon feet, which we have, but there are many more options, but he's specifically asking for the Solomon. Can we calculate anchor points for the S-Dome V 10 or 15 degrees, but with speed rail system, no rails from S-Dome V or V50?
Okay, there's a few points in there. So V-rail, as you said, we cannot use. We need a continuous rail at the moment, or the Dome 6. So we can use anchor points. However, not with the V-rail. At the moment, our base software, we should, well, hopefully in the next month or so, we should be able to have a bit of planning for these anchor points for both S-dome and D-dome. At the moment, we are looking at the Solmont foot as the like the main foot, one of the main feet that we could use for this, but in theory we could use it for any other feet as well. So at the moment, I don't think it is plannable in base, but it will be very shortly. And we have a product called the Dome Fix Pro Set, which is also in the Dome 6 webinar. We go through that in a lot more detail. It'd be a good place to find out more information. And yeah, I think that's about it actually. So.
Okay, yeah, that's thanks for this already. But the main point also was like the Dome V 15 degrees. I think that was also a question if you can put the peak of the Dome V 15 onto a regular rail and if you can calculate this. And I can also give this answer, it's no, we cannot, because we will have, and that's another question from Timo. He was asking, when will you release the 15 angle version of the SD Dome 6? Do we have a question, an answer for this already?
Oh, I don't know.
Okay.
We're hoping this year.
Yes.
Yeah.
And this is the reason why we are not able to calculate with the old rail and the Dome V15, because there will be a new solution coming up very soon with the Dome 6, also for the 15 degrees. So yeah, that's just in general for all the mixed questions in one sentence.
Yeah. And the Dome, I can tell you a little bit about the Dome 6 for the 15. It will be very similar to the Dome 6.10, and so the difference will be a slight change in the peaks and the SDs, but the process and the sort of advantages of the Dome 6 will all be carried over with the new 6.15, I guess.
Okay, thanks for that, and sorry for interrupting.
No, right. So clamps, hey? So yeah, we have two main clamp types for all of our systems really, and they are our mini clamps and our standard clamps. And our mini clamps are our newer products. So our V system and our Dome 6 system uses our mini clamps, and I'll just show them to you now. So here we have a mini end clamp. These come in black or silver, and they're suitable for modules up to or between 30 and 50 millimeters in depth, and this will cover the majority of modules on the market. So they simply just slide into this channel. Like that. Very, very simple. And then they are tightened from above with an Allen key or a hex key. Our other clamps or our other channel is the standard channel, and we use this in the Dome Classic system. And you might also know this from our speed rail or solid rail systems. And it's a little bit wider, it's a bit thicker, and we can use that with our standard clamps. So here's a standard clamp here, which slides in and then tighten from above. But then we also have a, so here we have a one end. Sorry, no, we don't. We have a mini clamp. Here we have a one end. And the process for installing this is a little bit different. You just push and click, and then you just tighten from above. So both of these are also available between 30 and 50 millimeters. So for all our flat roof systems, we are able to calculate or hold modules between 30 and 50 millimeters. So as we said before, all of them also come in single-sided or a double-sided. I've shown you all the double-sided of the classic V and Dome 6, but I quickly want to show the S-Dome and just an example of how that works. So here we have a S-dome classic peak, and here have some of the clamps we said before. Notice, so this is also a thicker aluminium, but the important point to note, and this is with all of our systems as well, is we have a windbreaker. So the windbreaker acts as effectively the second dome that is in a D-dome. So the D-dome doesn't need a windbreaker because it's supported, it's shielded by the other module. Whereas here we need something to ensure the wind doesn't come up underneath the module and blow the module away. So for the Dome Classic, which we have here, the fixation is with a screw. There's a threaded, this channel is threaded, so you can just screw it in. And yeah, that's lovely. Thanks, Klaus. And the fixation for some of our other systems are a little bit different. So here we have, this is the S-dome peak for the V-rail system, and this one is in 15 degrees. So at the moment, the V-rail system is the only system that we can provide in 15. As was asked a few minutes ago, the Dome 6 will also come in 15 degrees, but not at the moment. You'll notice here there are no holes and there is no channel. However, the profile is very similar to the dome, the D-dome V that we saw before. So this fixation is a little bit different at these points where the lines are, the material is a little bit thinner, and the windbreaker sits on here and is screwed through the material. So just a little bit different process. In terms of the equipment, I think the only other thing we have is ballasting. So Roman will talk a bit more about the importance of ballasting and how we calculate it through our software.
Okay, but Karen, if we are talking about the clamps at the moment, I think there is a good question who everyone would be interested in as well. So Miroslav was asking which of the domes can be used with this quarter clamping. Is there a length limit from which on the clamps must be used, or is it module specific?
So quarter clamping is a term we use for clamping the modules instead of on the corner, but on the within the module, about a quarter in. That's what I call quarter clamping. And just for those who do not know what it is, we use a different clamping structure. And these sit in our standard channels. So we can only use the quarter clamping with our Dome Classic. So they will sit in here. This is then tightened. And I believe at the moment, this is plannable in base, only in the D-dome though. So you're unable to plan this in S-dome. That I believe that will be coming in the future as well, but the calculation is a little bit different. The heights for the modules, I believe, are the same. Roman, is that correct?
It's not quite true. It's from 34 millimeters up.
Oh, so from 34
yes,
to 50
so
millimeters.
you might get into trouble with 30 millimeters or 32 millimeters modules. Yeah. So please be aware of that.
And you can see that is just because of the height in here is actually nowhere for it to go any, like we are actually unable to go any further. So.
Exactly. And one more little note, for the S-dome, the quarter clamping is not available. It's a special construction, a bespoke solution. The main problem is the windbreakers, which are having pre-drilled holes on the side. And if you prepare the rails and also the peaks more into the center of the module and you want to clamp on the long side, you won't be able to fit the right windbreaker on the right position. and that's why it's a bespoke solution. So just for you guys to know, as an information, we are just able to calculate in base in our program the D-dome system.
Yeah, and so everyone at home should be able to do that as well. It's just one of the options in the software.
Very true. Thanks for that answer.
You're welcome. Yeah, so while we have this here, we can then just discuss the ballasting. So all of the rails are able to withstand a little bit of ballast, but usually we will supplement the rails with what we call a speed porter. So the speed porters are, they just sit over the top of the rail. These are the speed porters for the Dome Classic or the Dome 6, because it's just for the speed rail. And here we have one for the Dome V or the V rail. And they just sit on top of the rail like so. And then you're able to build up with bricks in here. And so usually this will sit underneath the modules. And as you can see, not very movable, which is good, nice and firm. Perhaps too firm. We're also able to put a little bit of ballast underneath the D-dome as well. And for the majority of cases, this should be enough depending on your loads. However, if you have a place with high wind loads or high snow loads, you may need extra ballast. And then we refer to it as a porter, and we connect this rail to a rail which would be over here. And the ballast then sits both underneath the module on the rail, but also between two rails. Roman, I think that is all from what I had planned to show today. So if there are no more questions, I will hand over to you.
Okay, yeah, there are no more questions right now, which are fitting at least. Thanks, Karen, for all the information you just gave us and the presentation of the parts. So I would just continue now with the online part. If there are no more questions, nothing came up now. Okay, let's just start then. I would just share my screen as I did last week. I don't know for those of you who have seen the webinar last week, pretty much doing the same, just showing you a bit about our website. We have a new design on our website and how to find some information which you might need for your project. So let's just start. This is the our website. Obviously, it's k2-systems.com. And first of all, just choose the language you want to have the website, and this is where you find it on the top right corner. Right now it's preset in German. I will just switch into English now. And also as an information, if you switch to one of the other languages, you will get into our partners from, for example, from Mexico or from the US or wherever you want to switch to. So we change it to English now, just for you to understand all what I'm talking about and where to find the stuff. So we are talking about flat roof systems. The first thing I want to show you, which is very important on flat roof systems, is how to find how to measure the friction coefficient. And we have a little sheet in, like for example, you press the product, this button, and you go into the flat roofs first. And this is the area where you see all our systems now. So if you already know which system you want to choose, you're good. And if not, then you're able to compare the different systems over here if you click on either of the systems. Or what you also could do, you go down to download section, and there you have brochures for the flat roof systems. Also, which is quite simple and very fast to have a comparison between the roof systems, is this matrix. So as you see here, there's the S-Dome Classic compared to the S-Dome 6, the D-Dome Classic to the D-Dome 6, and so on the second page. So this is quite quite handy, I would say. You can also download it, save it on your computer, and every time you have a new project to plan to, you have a quick look into this matrix, and you decide which system you want to use. Then also the second part, what I wanted to show before we come closer to the more important, the friction coefficient part, very quick. As you all know, sometimes there's the requirement of lightning protection. So we have different clips, which are called TerraGraph, which you fit in between the module, the rail, and the module clamp. And this is how you get to know which clamp you need for which system, and also how to prepare and fix it. And there's a little table where you actually see very easy which clamp do I need for which system of K2 systems. So, and now we want to continue for the technical information. And then you go for the overview. And very important, Kyron was mentioned it already about the friction coefficient. We go onto the flat roof, and then also, where are the, sorry, the product information, not the overview. And we are on the flat roof systems, and find on the browser, where's the download button? I'm sorry for this. If you just click on DOM 6, for example, no, sorry for this. Very sorry. I think we are still here on the products and flat roof. This is where we can find it. If you click on one of the systems and we try to find the downloads, and this is where we find for the accessories, the brochure, and the product data sheet. Well, there's the assembly manual as well, and the checklist. And also I will continue to show later on about the other part, which I was just talking about. But better if we are continuing right now with base, and while the questions coming up, then I will show directly on the website. I think that's the easier way. So if we want to start planning our project, we go onto K2 Base. And there's a direct link on our website where you have demo videos and register now, where you can just start K2 Base directly. So I did sign in already. For those of you who haven't signed in yet, it's just very simple. You will get a confirmation email, and then you can just start planning. This is a demo, so just for webinars, for example, but this is an account we opened up for this. So the language will be changed to English now for you guys to understand everything what I'm doing. And for me also very easy to explain. So we will start with a new project, and we will do the planning on our headquarters like last week. It's Industriestraße 18 Renningen. This is where our headquarters is, and here you see it's a picture just like in some maps, for example, Google Maps or something. Here we are able to type in some information about the project. For example, the project name, we just call it Webinar Flat Roof. And then you're able to change the name of the author, like this would be me then, and then the customer and also the contact of the customer. So today we are planning one of the flat roofs, which are around here. And I think this one would be very nice, not too big and easy to show you something. So next step here, first of all, we save, which is on the left-hand side. So we save the project and continue to draw the roof. So next step would be clicking onto the roof button here and find our roof in the little red square. We are able to zoom in and out just by rolling the mouse in and out. And also we are able to move left and right. So most important is that you have the roof, which you want to draw, is in the red square. If the roof is not available yet, if the building is not there, you're always able to draw on an empty paper. So you can always draw here. Right now, we want to pretend to build a PV system on this roof. So we have this in the center of the red square and press the add button. So now today we're doing the flat roof and it's rectangular and it's even. It doesn't matter if it's like gravel or a green roof, membrane or bitumen. It doesn't really matter. It's just always this button because it's always even. That's what a flat roof is. And now we see the cursor change to a little cross. We're going onto one of the corner of the roof. One click with the mouse, you see a red line is coming up. We're following the roof. Second click, and it changes to green, to a green square, which we are able to move up and down. And a third click on the mouse enables us to see the whole roof, which we were drawing. Then you have more information about the roof to type in, which are very much needed in this point because it changes the ballast values if you have different heights of the roof. For example, if you have a very high roof with 25 meters or 30 meters, there's a lot more ballast needed than on a roof with 8 meters. And also, obviously, which we're coming up for the loads. But for now, we just type in, for example, 12-meter high roof. And let's say the roof pitch is just 1 degree. And we have, for example, bitumen. We're able to choose here one of the different roof layers. So we use a bitumen now. The parapet wall, you need to have this information from the customer, or at least you need to type something in, which is sometimes a assumed value if you don't get it from your customer, but you need to have a value in here. And now we're coming back to the friction coefficient. And for those of you who don't know what it exactly is, you're always able to press this little question mark. There you can see how to actually measure the friction coefficient, or what I was going to show you before on our website. If you just type in on the search button, friction coefficient, you will be able to find a PDF file and also a video on YouTube. We are able to see, for example, accessories. If you click on here, we're here to learn more about how to measure the friction coefficient. I'm not going to click on it now, but this is what I was going to show you before. We have a little video, and also we have the how to test it. For example, there's a little protocol, a little PDF file to download. I'm not going to go deeper into this, but this is very important just for you to know. For now, with the bitumen roof, we are choosing the 0.6, for example. And then we have already typed in all the needed information for this roof. What we also could do is switch into the 2D view. And with this little ruler here, we can type in the direct measurements of the roof. Let's say it's 50 meters long and 18.5 meters wide. And we already finished with drawing our roof. Next step, obviously, saving again. And then we continue.
Roman, which do you prefer, the 2D view or the satellite view?
Well, I do prefer at the beginning the satellite view, because if you have obstructions on the roof, just some obstacles like chimneys or windows or whatever, you see them on the map already here, as I just changed now to satellite view. But then if you want to type in exact measurements, you need to have the 2D view. This is only possible to click on this value while you're on the 2D view and not on the satellite view. This is not possible.
Oh yeah, so maybe like 2D view would be better for new buildings perhaps that you just have the designs for.
Exactly.
Okay.
And also for the planning, you're getting less distracted by the other buildings around. You just have one white paper with your roof on it, makes it a bit easier for the eyes as well. And also another thing, if we have obstructions, like we do now here, we can draw them, and we are not only able to add and draw the roof on a certain size, but also the obstruction. So if we're on the 2D view, we're able to set the exact size. Let's say the chimney is 2 meters wide and 2 meters long. So we have a little square, and then we're even able to position it on the right point. So for example, we have it 4 meters from the west side and 3 meters from the north. So now we are able, with a 2D view, we are able to put it directly on the right position. If you have it in your plan, the position. Otherwise, you're able to draw the obstruction in the satellite view as well. Any more questions to this, Karen?
No, not at the moment. But thanks for the answer of that and the thoughts.
Okay. So we did draw the obstruction. If we continue now, we are able to write some remarks. And as I said before, sometimes we don't have values. So for example, we write down the parapet wall height is assumed, or something like this. Something like this, just any note, any remarks on this project. So next step would be designing our module arrays, designing our module fields, and also choosing which module we want. This is the first step here. We have a database with a lot of different manufacturers from modules, and the first top ones are the ones you're using quite often. For now, we're using just a Trina and a 365, for example. It's right now a basic module with a regular length, not the smallest, but this is what the sizes are right now, just for you to show. So next step would be module arrays. We are choosing which system we want to use. And for now, we're going with the classic system, the regular classic system, and draw one of the module arrays. And we want to have it. We see, that's why I'm still in the satellite view. We see here's the obstruction. Here's a big field where it's free. So we can just draw the module array over the obstruction, and it will still plan no modules because there is the obstruction and you won't be able to build modules here. So the tool is actually smart enough to realize, okay, we need to leave these modules out. But then, as I said before, I prefer the 2D view. So no buildings around which are restricting you. It's just very easy and simple. So you see just the modules. We are able to plan the S dome right now. Actually, I wanted to have the D dome. So even if we did plan the S dome already, we're able to change the system, just swap it here in the field of mounting system. And then we're able to even move it left and right on the roof, wherever you want it to. I think this is clear so far. We're not having many beginners in this webinar. If it's not very clear, you're always able to look something up in our tutorials, which you can find right here as well. There are many short clips and videos how to use base, and they won't take long. It's just 2 or 3 minute clips, but they can help a lot. So back to the planning. Let's say we set everything up here. Continue on, I'll just show this, be a bit bigger. We have 7 modules, double modules in a row. So it's 14 modules here. But with the classic system, you see, we need to have a thermal gap here. So we are only able to plan 5 double modules next to each other. And obviously, the more modules, the bigger the field is, the more modules we have, the lower the ballast is. So what we would do in this case, we would change the thermal gap into the middle. So we have two same size module blocks, if possible, of course. Also, the horizontal one, we are able to change here or type something in. So next step is filling in the loads and the terrain category. as we have typed in the address, the exact address, K2 base has a lot of information while you type in the address already, just like the ground elevation, then also the wind load and the snow load zones. The only thing you have to type in and change is the terrain category, because then obviously we don't know if we are in the surrounding suburbs or right in the city center, or if you're on the coast. That's what base doesn't know until now. Maybe there's something else coming up. But now we are in the terrain category 3. So I changed this. And as you see, the peak velocity has changed from, I think, 0.52 exactly to 0.49. So a bit less wind. And that helps us to reduce the ballast a little bit. Next step would be choosing the building protection mat. As we have the classic system, we have 2 different building protection mats. The aluminum one is for the foil roof and for the single ply foil, and then the bitumen and, for example, gravel roof or green roof, you choose just the regular one, which we're doing now. And then the calculation is done. That's pretty much all you need to do. What else you could do is right now, if you don't know how much the loads are, or the force is pushing onto the modules, you're always able to click on the module, and the next window is going to open with the results, and there you can see the loads on the module. And also another little trick is if you click directly on a rail, you're able to see the rail length, and therefore you can just choose the right rail length you want to use for your system. Of course, right now is the 5.5 meter the best, but then maybe you choose the 4.4 as well, or the 3.3. So these are little options you have. And yeah, that's, I think, pretty much all for the first planning. We were talking about the quarter clamping. I'm going to show this really quick. We have the system type here to choose, and also the mounting option. We are still on corner clamping, but we are able to choose the quarter clamping as well. And you see the rails just move inwards into the quarter position of the modules. So this is an option we have for very high snow loads, like areas with very high snow loads, or very large modules, which are coming up very soon. Now I'm changing back to corner clamping and show the difference between the ballast values. You see it's not very high at the moment, but if we change, first of all, we have only 5 next to each other, and then we need a thermal gap. And if we change to the D-dome 6.10, we're able, that's 1 more row. So we get bigger module blocks, and therefore we have less ballast. And this is incredible. As you see this, there's no ballast needed in the center area, only on the outside corner and field area, the outside area. This one, of course, there's a thermal gap here now. That's why this is a single one, and that needs a lot of ballast. So you would actually choose to have the thermal gap not here. You would move it more inwards, but this is, as an example, it's good right now to see. And then, yeah, you have just the most ballast is on the corner area. See 22 kilograms here, 22 kilograms in here, and 14 here. But 3 kilograms here, somewhere around here, and 7.5, and nothing in the center point. So you see there is a big difference of the different systems you're using. That's why it's always good to compare as well. At the end, one more thing. Here in the summary, this is what you see, the bill of materials, the different roofs. You can obviously draw more than one roof. And then you have also the amount of the modules for each roof, which module you're using, all this information, which you get also in the PDF file, the report, which you can generate on here. I will do this just now to show you how it looks with all the information you were typing in before. And then before we open this, you're able to download also the bill of materials as an Excel file, the ballast plan, or you just push forward and you want to plan the inverter, you can go to K2 Plus and move forward to one of the different inverter manufacturers, just for the planning. Very easy. one last thing before we open this PDF file. Oh, now let's do this first. Let's just open the PDF file, have a look through. You see all the information you're writing in, the project name, the author, when, like the date when it was planned, and then all the project data. And you have a nice little report all in one PDF file. You have the layout, you know, the rail length, the different rail lengths. You see the ballast plan. It's all in one PDF. So one last thing, if you have any questions, or this doesn't work right now, but if you have any questions regarding base and you want to ask us or our partners, you need to download the base file, because this is your own account. We are not able to look into your account when we are not able to see your planning. So what you gotta do is download the base file and send it to either us or our partner. Okay, I think this is for now what I wanted to show you. Karen, are there any more questions for now?
There's one, not necessarily about base, but I think a good question, and it is regarding the ballast. So we provide a base report and potentially but also the option of a ballast plan. So this information is just for the customer. And someone has asked, do we provide the ballast as well? And so it's not really something you need to answer, but just thought we could bring it up and say that the ballast is not provided by us. So it's a lot cheaper generally to get ballast locally. So there is no point us shipping bricks everywhere when bricks are usually available, you know, in most towns. So in terms of the ballast question that we just had, we provide all the material to hold the ballast, but the weight itself must be provided by someone else.
Exactly. So I would say we just start a little Q&A round.
Oh, before that, Roman, we actually just a few things we I think not necessarily didn't answer, but something that I didn't show before that you mentioned was the terraglyph, which I thought would be really easy to show because it's quite practical. So it's just a little piece of metal, effectively, with some teeth on the end, and these dig into the module frame without damaging, but provide an electrical connection. All right, so for part of the bonding or equipotential bonding, these are very important to ensure that if you have any, like a lightning strike or a power surge, that the current's not going through the solar panels and it's going through the outside of the frame into the rail, and then potentially into, or then hopefully into an earthing system that is connected to the PV rail. So that was just a quick little thing. There was probably, and then there was two other points that we didn't discuss, and they were that we are able to install this with fall protection. And so we integrate that with a company called Innotech. So this is something not plannable in base, but it is something we can provide. And we also are able to put this on what we would call a floating structure above steel girders. So we discussed the high snow loads with quarter clamping and the roofs with the Dome Fix Pro set. But I just wanted to bring these other points up as well.
Karen, we have one more question. Very good one. Is there accessories to use pebbles or gravel as ballast?
Yes, there is. So we use a similar setup. So we generally use our classic system with some PE plates. Roman, there's a little bit of information online, so maybe we could go through this while discussing it.
Mm-hmm. Okay. Do you want me to show the screen? Okay.
Yeah, I think that would be good.
Okay, I will just show my screen. And we are moving back to our website. And I think the easiest way to show is if we're moving straight to our price list, because this is where we can find the PE plate. Now I need to, very sorry, just the overview. So the general information. I think this is where you can find it. No, not right now. Okay, then.
In the products manual, I think, Roman.
And the product?
General catalog.
There's a general catalog at the back, at the last point.
Oh yeah, there it is. That's what I was looking for before already. Okay, yeah, there's the catalog. And if we open this one, and we're scrolling up to, this is the accessories button. We can click to go forward quite fast. There is, first of all, these are the TerraGriff, which Karen was just showing live.
Yep.
And then there's also the PE blade right here. You see it's made up just like a trapezoidal sheet, and you just screw it directly onto the rail, and you're using this for gravel on top, and then you have the ballasting done.
Yeah, and so this we can use as a, instead of extra ballast. So often roofs will have this pebble or gravel on top of the roof anyway. And so the ballast, the existing gravel can be sort of pushed away, this PE plate laid down, and then the gravel put back on top. So depending on the density of the gravel, you may not need any extra ballast at all, but that just depends on the project.
Exactly. And while we're already on this page, we were talking about the friction coefficient before. We are providing the tool for this. This is right here. Also, you can find it in the price list, the catalog, just for you to know. Okay. So what are other questions?
Just let me look now. I have
one of the questions is, can we enter the weight limit of the roof during the ballast planning? I mean, a limit in kilogram per square meter.
And the answer to that is no. So we're not really providing a system that is designed for a roof. We're designing a system that will not leave the roof. So the values we put in are, it may not be possible to achieve this minimum of, in the example, I think we had 30 kilograms per square meter. And so if the project has some higher wind loads or is 3 degrees with maybe not much friction, then it will require this ballast. And then there we have ways of reducing the ballast if necessary through the dome fix pro set. This is not plannable too much in base. There's a little bit that will be coming up soon. But in theory, we're not looking at the building structure. We're looking at ensuring the PV system does not leave the roof.
Exactly. But while we're talking on it, I'm going to show my screen again so you know where to find it. We generate the report again. And for you, just as an information, once you downloaded the report and opened it, there is a little table on one of the pages of the report, which shows the exact kilogram per square meter, which is right here, the dead load in this little table of the specific loads. So you can see the first array was bigger, as you remember. We have just only 13 kilograms per square meter. And then the second one would be including the ballast, it's 27 kilograms per square meter. And this is only because we have one very large array and one very small one. So if you would split this up to 2 blocks on the same size, then this one would be changing as well.
Yeah. And
okay. So I would say, let's do the question and answer round. Yeah. If someone wants to talk to us directly, you can just lift up your hand now and we'll put you in.
Yeah, so this is a chance if your microphone is working and if you want to have raise your question verbally to either myself or Roman, now's the opportunity.
Okay. It doesn't look like anyone wants to talk to us, Karen, or we were just clear with everything.
Yeah, I hope the latter, to be honest. Yeah.
Okay, then. If there's no more question right now, Karen, do you want to stay a few more minutes to get some more questions, if there are some?
Yeah, I'll just slowly wrap up, but I'll stay around for a few more minutes. So if anything does come to anyone, either type it in or you can raise your hand and I'll happily ask. But so while everyone's still here, thank you very much for joining us again. This will be tomorrow or the next day, you'll be sent an email with all the links that we have discussed, all the locations of where to find this information. If you're with our webinar newsletter, you'll know that we have webinars coming up each week on a Wednesday at the same time. So next week, we will be discussing trapezoidal roofs. I encourage you all to get involved if that is of interest, or if that is a project you're potentially will be selling. Roman, thank you very much for your time today.
Thanks, Karen. Thanks for presenting all the parts and explaining very well. Thanks to everyone for listening. Thanks for showing up, and hope to see you next week again. And I'd say until then, bye. See you later.
Yeah.
There was one hand sign button. Maybe it wants to lift it again.
Yeah, I think we just had someone raise their hand. You're welcome to ask. We'll be here for a few more minutes.
But you have to activate the hand sign.
Yeah, but you must put your hand back up virtually. Okay, thank you very much, everybody. We will be closing the webinar in the next. No, we have one.
Not the hand sign, but a text question.
Oh, text question. So we have a question regarding the stones, and so yes, you can put them on directly onto the stone. So however, if you do that, then you will need more ballast on top of that. So it just depends a little bit on what is best for the roof. If it's already overloaded, you probably do not want to put too much more weight on it. However, if you want to do a little bit less work, it might be easier to lay it on top of the stone. So you are able to, but both options are a possibility. So thanks for the question. Yeah. Okay. Thank you very much, everyone. We will be closing it now. I hope to see you next week, and if not, have a great time planning solar. Bye.